Integration by parts is a method used when integrating a product of two functions, where one function is chosen to differentiate and the other is chosen to integrate. In words, the rule states that the integral of the first function times the derivative of the second function equals the first function times the second function minus the integral of the derivative of the first function times the second function. In symbols, this is written as integral of u times dv equals u times v minus integral of v times du. A reduction formula rewrites an integral in terms of a simpler version of itself, usually with a smaller power. We apply this simpler version repeatedly until the integral becomes easy to evaluate directly. Let's work through an example. We want to find the integral of x squared times e to the x dx. For integration by parts, we choose u to be x squared, since it becomes simpler when differentiated. We choose dv to be e to the x dx, since it integrates easily. Differentiating u gives us du equals 2x dx, integrating dv gives us v equals e to the x. Applying the integration by parts formula, the integral of x squared times e to the x dx equals x squared times e to the x minus the integral of 2x times e to the x dx. The remaining integral of 2x times e to the x dx is still a product of two functions, so we apply integration by parts a second time. This time we choose u to be 2x and dv to be e to the x dx. Differentiating u gives us du equals 2 dx. Integrating dv gives us v equals e to the x. Applying the formula again, the integral of 2x times e to the x dx equals 2x times e to the x minus the integral of 2 times e to the x dx. The integral of 2 times e to the x dx equals 2 times e to the x. Putting all the pieces together, the integral of x squared times e to the x dx equals x squared times e to the x minus 2x times e to the x plus 2 times e to the x plus a constant of integration c. To check this answer, we differentiate the result term by term. Differentiating gives us back x squared times e to the x, so the answer is confirmed correct. Now let's set up a reduction formula for this same family of integrals. In words, we define I sub n as the integral of x to the n times e to the x dx. Following the same integration by parts steps, with u equal to x to the n and dv equal to e to the x dx, we get I sub n equals x to the n times e to the x minus n times I sub n minus 1. Applying this reduction formula once, with n equal to 2, gives us I sub 2 equals x squared times e to the x minus 2 times I sub 1. This matches the pattern we found earlier by applying integration by parts twice, confirming the reduction formula works. Next, let's find the arc length of a curve. In words, the arc length formula states that the length of a curve equals the integral over the given interval of the square root of 1 plus the derivative of y with respect to x squared. In symbols, this is written as arc length equals integral from a to b of the square root of 1 plus open bracket dy by dx close bracket squared dx. Consider the curve y equals x to the 3 over 2, shown here in a two-dimensional view, from x equals 0 to x equals 4. Now watch as this same curve lifts into a three-dimensional view, tracing the identical path above the xy plane, so the same shape can be seen from a new angle. To find the arc length, we first need the derivative of y with respect to x. Differentiating y equals x to the 3 over 2 gives us dy by dx equals 3 over 2 times x to the 1/2. Next, we square the derivative. Squaring 3 over 2 times x to the 1/2 gives us 9 over 4 times x. Adding 1 to this result, the expression inside the square root becomes 1 plus 9 over 4 times x. So the arc length integral becomes integral from 0 to 4 of the square root of 1 plus 9 over 4 times x dx. Using the reverse power rule for integration, we increase the power from 1/2 to 3 over 2 and divide by that new power, then divide again by the derivative of the inner expression, which is 9 over 4. Dividing by 9/4 is the same as multiplying by 4/9, and dividing by 3/2 is the same as multiplying by 2/3. Multiplying 4/9 by 2/3 gives us 8/27. So the antiderivative equals 8/27 times, open bracket, 1 plus 9/4 times x, close bracket, to the 3/2. Evaluating at the upper bound, x equals 4, the bracket becomes 1 plus 9, which equals 10, so this term equals 8/27 times 10 to the 3/2. Evaluating at the lower bound, x equals 0, the bracket becomes 1 plus 0, which equals 1, so this term equals 8/27 times 1, which is 8/27. Subtracting the lower bound value from the upper bound value, the arc length equals 8/27 times, open bracket, 10 times the square root of 10 minus 1, close bracket. Evaluating this numerically, 10 times the square root of 10 is approximately 30, 1.62, so the arc length is approximately 9.07 units. To check this answer makes sense, we compare it to the straight line distance between the two endpoints of the curve. The straight line distance from the point 0, 0 to the point 4, 8 is the square root of 4 squared plus 8 squared, which is approximately 8.94 units. Since the arc length of approximately 9.07 units is a positive number and slightly longer than the straight line distance, the answer is sensible and confirmed correct.